In this lesson, you will learn to solve problems using polynomial equations. Now, as I begin this lesson, keep in mind that there are an infinite number of ways that you can apply what we've learned to actual examples. So the examples we're going to give here are some very basic examples where we're going to explain to you the thought process. And the thought process can be carried to any type of question that you're asked. Okay, and the most difficult part of these word problems is setting up the equation. Once you set up the equation, then you can solve using techniques and different information that we've learned in the previous lessons. So I'm going to walk you through 3 examples and try to follow the thought process. So first example, you're told that the sum of a number and a square is 20. And the question is to find the number. Now for any word problem, you want to begin by identifying what your variable is. What is it that you're trying to find? And here it tells you what you're trying to find. You're trying to find the number. So we'll let the number equal x. And then using that, we can set up an equation where it says the sum of a number and its square is 20. Well, the sum means addition, so we're going to be adding the number, so x is the number, and the square. So you're adding the number and the square of the number, so x plus x squared, and it says that's going to equal 20. So my equation is going to be x squared plus x equals 20. And now we need to solve. We have the equation, which is many times the most difficult part, and now we need to solve this equation. So to solve this, we want to use the zero product property, where we have 2 things multiplied together equaling 0, and then you can set each part equal to 0. So for this one, you want to get this equal to 0 first. So we do that by subtracting 20 from both sides. Now we have x squared plus x minus 20 equals 0. And then from here, we want to factor. So we want to factor x squared plus x minus 20. It is a quadratic trinomial. So when I factor this, I know that it's going to be 2 things multiplied together. And we have 4 parts. And to get x squared, we need to multiply these first terms together. So that's going to be an x times an x, which would equal an x squared. And then we need to ask, how do we get negative 20? And that is found by multiplying the last 2 terms. So how do we get negative 20? Well, it could be a 1 and a negative 20. It could be a negative 1, positive 20. It could be 2 and a negative 10. Negative 2 times a positive 10. And then 4 times a negative 5, or negative 4 times a positive 5. Now the question is, which pair of numbers do we want to use? Well, to do that, to determine that, we need to figure out which ones add up to give you the middle term. The middle term is a 1. It's a plus 1x. So how do we get a positive 1 back out? Well, we see negative 4 and 5 would add together to give me a 1. So that's what we're going to use. We're going to use the negative 4 and then the positive 5. So now I have x minus 4 times x plus 5, or x plus 5 times x minus 4. The order does not matter. And now from here we have 2 numbers multiplied together equaling 0. X plus 5 times x minus 4. So we know that because 2 numbers are multiplied together equaling 0, that one of those numbers must equal 0. Either x plus 5 is 0 or x minus 4 is 0. So we can solve this and get x equals negative 5 or x equals 4. And that is my solution. And just double check your answer. Make sure that everything works when I plug it back in. Negative 5 plug in for x would give you negative 5 plus 5. That's 0 times something equals 0. So that's going to equal 0. Plug a 4 in. We have 4 minus 4, which is 0. So 0 times 9 equals 0. That's also a true statement. And also, we probably should just double check, make sure that it actually answers the question. So the sum of a number and a square is 20. Well, the sum of a number and its square if we take negative 5 and square it, and then add that with the number, does that equal 20? Well, yes, 25 plus a negative 5 equals 20. That is true. So that one works. And if we do the same thing for 4, the sum of a number and its square equals 20. So we have 4 plus 16 equals 20. That works. So that is a true statement. So my solution would be x equals negative 5 or x equals 4. The next one says define two consecutive even numbers that have a product of 35. So we're trying to find two numbers. So the first number we'll let be x, and the second number, based off the first number, we know because it is consecutive and even that the next number after that would be 2 more, right? If we had, for example, two even numbers, like 4 and 6, for example, the next number is found by adding 2 to the 4. 4 plus 2 gives me 6. So the first number is x, and then if we add 2, we get the next number. And it says the product is 35. So we multiply x times x plus 2, that equals 35. So then I can solve this. So to solve this, we have x times x gives me x squared. X times 2 gives me 2x. And then we want to set this equal to 0 by subtracting 35 from both sides. Now we have x squared plus 2x minus 35 equals 0. Now we can factor this, and we know that to get x squared, we have x times x. To get 35, it's going to be either 1 times 35 or 5 times 7. So I know 5 times 7, if 1 is positive and 1 is negative, then I'm going to get a negative 35 when I multiply. And this one, if I add these two together, I'm going to get a positive 2. So I know when I factor, it's going to be x minus 5 and then x plus 7. So we factored and then solved this by setting each part equal to 0. So x plus 7 is 0 or x minus 5 is 0. So x would have to be either negative 7 or x equals 5. Now go back to the original question. It says here, first number is going to be x, second number is x plus 2. So if the first number is x, we found x is negative 7 or 5, the first number could be negative 7 or 5. And if the first number is negative 7, then the second number is negative 7 plus 2, which would be negative 5. And then if the first number is 5, the second number needs to be 2 more than that, so 5 plus 2, which is going to be 7. So that would be my solution. And actually, do take note, this original question should be saying odd instead of even, because notice our solutions are both odd solutions. So the setup and everything is exactly the same. Okay, the way we solve is the same. The only thing is the question should have said odd here instead of even. Now for the last example. Here, this one involves some geometry, because it says you're designing a poster that has a rectangular print with a uniform border. The print is to be 3 times as tall as it is wide, and the border is to be 4 inches wide. If the area of the poster is to be 112 square inches, find the dimensions of the print. Now when you begin one like this, it's always helpful to draw yourself a picture. So here's a picture of our poster. We have the print here on the inside, and then the border is around on the outside. Okay, let's draw some things on this picture. So we're going to draw some information that's given to us. We have the print is to be 3 times as tall as it is wide. So the width would be right here, W. So the print is from here to here, that's W. And the height is going to be 3 times the width. So from here to here, that's 3 times the width. And the border, it says, is to be 4 inches wide. So the border all the way around is 4 inches. So from here to here is 4 inches, there to there is 4, and then here to here, and then from here to here. Those are all 4 inches. So the question is, saying that the area of the poster is to be 112 square inches. So the entire poster, the entire big rectangle, the area is 112 square inches. Well, how do you find the area of a rectangle? Well, the area is going to be equal to the length times the width. Well, we know the length and the width of the print on the inside, but the question is, how do we find the length and the width of the entire rectangle? Well, we know that if we add this 3w from here to here, if we add this 4, and then this is 4, if we add those together, we have 3w plus 8. That's going to be for this height. And the width, same concept. You take 4, this 4, right here, that's 4, plus another 4, that's 8. 8 plus that w would be the entire width of the poster. So we have w plus 8. So now we have the length and the width, and we just need to figure out, what exactly is it. So using what we know, how do we find that exact length and width? So the formula is area equals length times width. We have the area as 112 square inches. So we know if we take 3w plus 8, which is the length, or the height, I guess, and then the width is w plus 8. Multiply those together, we're going to get 112. So we multiply 3w plus 8 times w plus 8 equals 112, and then we solve. So to solve this, we want to distribute. So 3w times w, 3w times 8, 8 times w, 8 times 8. When you do that, you have 3w squared, and then here we have 24w. 8 times w is 8w, which gives me 32w when you add those. And then 8 times 8 is 64. So then solve this by setting this equal to 0. So we subtract 112 from both sides. Now we have 3w squared plus 32w, and then minus 48. And now we can factor. So to factor, we know it's going to be something times something. So it's going to be 3w times w to get 3w squared, but then how do we get negative 48 right here? So to do that, we're going to multiply these two numbers together. And if you want, you can go through the whole process to find that. So to do that, if we take 3 times negative 48, we're going to get 24, carry the 2, get 144. And so the question is, how do we get 144? Well, what do you multiply to get 144? So you could do a multiple of things. And this actually needs to be a negative 144. It's 3 times negative 48. And one way to get negative 144 would be a positive 36 times a negative 4. And we know that if we add those together, we're going to get 32, which is the middle term. So what we have is going to be 3w squared, and then replace the 32w with the 36w, and then minus a 4w, and that's going to be minus 48. So then I want to group. I want to factor by grouping. So I can group this together and this together. When I group the second set of terms together, because of this minus sign, I need to make sure I change this from a minus 48 to a plus 48. So now I can factor out from each set of parentheses. This first set of parentheses, it's got a 3 and a w in common. And I'm left with a w and then plus 12 over here. And then minus, and then the second set of terms, I can pull out a 4. Now I have w plus 12. So now, notice they both have a w plus 12 in common. I can factor that out. And I'm going to have left in parentheses the 3w minus 4. And that's going to be factored. So now we have w plus 12 times 3w minus 4. Now we set each part equal to 0. 3w minus 4 equals 0, or w plus 12 equals 0. And then when you solve this, you're going to get w equals 4/3 or w equals -12. Now take note, the width can never be a negative number, so therefore my solution would just be the positive number. So w would be 4/3. So these are just 3 examples that I've shown, but there are a plethora of examples where you could use the concept of solving polynomial equations. And this concludes our lesson for today. We will see you next time.